Hello viewers, welcome back to Machine Art Channel. And if you're joining us for the first time, welcome. Today on this channel we'll be talking about the difference in local time. Hey guys, I don't know how many people you know in the world, how many locations you know in the world, but have you ever been communicating with a person from another continent and you hear the person saying that this is evening when it is morning time in your place? Have you ever, do you know the reason for that? Like, if they ask you guys to explain the science, the mystery, or the reason for difference in local time, can you do it? Do you know it is very simple? You know, we have different types of movements, right, in the solar system. We have the movement of the Earth on its axis to give 24 hours. We have the movement of the Earth around the Sun to give one complete revolution. That is to give one complete year. Then we have lunar movement of the moon around the Earth to give one complete month. Now, the reason why you experience difference in time is because of Earth's rotation. You know, once it is done, or as the Earth rotates, every part of the Earth that is facing the Sun, the eastern part will receive sunlight before the western part of the Earth. Do you understand? Now this is the reason why. Then do you know the reason for the difference in local time? The reason for the difference in local time, to say that it is morning here, then evening there, is because of the distance between you and others. When you talk about the longitudinal location away from the center of the Earth that cuts vertically, then you will be talking about the difference in time. Now you see, time could be increasing or decreasing from your location. The mystery can be solved very simply by what we call the coordinate system. The coordinate system is made up of the latitudes, the longitudes, and the elevation. I'll be giving you a graphical illustration and teaching you how to easily calculate, such that even if you're not a geoplanner, even if you've not gone to any part of the Earth to know what the time difference is, if you're smart enough to just follow up, you'll be able to calculate. Now, let us say you ain't able to calculate, but you'll be able to understand the difference, right, in local time. And that is the reason why right now, as it is afternoon in many parts of Africa, it is morning time in North and South America. I know some North Americans may think that it is morning in their place and maybe afternoon in Africa, and only then because they're in America. Oh no, it is because of that vertical line that cuts across like this meter rule. So will be decreasing. This is the reason why if you have friends and relatives in South America, you will notice that their time zone works almost the same way. Yes. Now, even in North America, you realize that the time is not all the same. Like some people may be behind by 1 hour, 2 hours, 3 hours. Others may be ahead by 1, 2, 3 hours. Right? So you want to understand the mystery? Like when you hear somebody say good morning on the phone to someone when it's afternoon. Sometimes it will be 3 p.m. in your place and a person will grab a phone and say good morning Miss Porter or Mr. Harrison or Mr. Whitewash, white water. Right? Alright. You see, it may even be 4 o'clock and you hear somebody say good morning, how are you? That's because it is actually 10 o'clock over there, 10 a.m. It may even be 5 o'clock, you hear good morning. That's because it is 11 o'clock over there. So, want to understand the mystery? Simply, let's do some geographical science, the father of all subjects. So, alright guys, as you can see, it's very, very simple, right? You know, I told you that the difference in position on the Earth's surface and the difference in local time is not different from the difference in the lines of latitude, or as a result of the effect of the lines of latitude and lines of longitude, right? And then we have elevation. Elevation simply means height above sea level, all right? Above sea level, you know the level of the sea? Yeah, you can calculate the height of a place above sea level. It's very simple. Now, to understand why we have difference in local time, why some places might be ahead of other places in time, and maybe it could be 10 o'clock in a place, and it may be 8 o'clock, maybe a.m., p.m., or it may be 10 o'clock in your place, and another place may be recording 12 o'clock. Right? You want to understand the difference. Now, check it out. So, let's go ahead and clean the lines of the latitude and longitude elevation, right? You know that the world is spherical in shape. It's not a complete circle. You know, if you've ever seen an avocado, not even the shape of an egg, it's not a perfect shape of an egg. But if you've ever seen an avocado, right, the earth is like that. It's not a complete circle. However, the earth is divided into 360. Even though it's not a complete circle, it's spherical. Alright? It's spherical, meaning not round like a complete circle, but it's still somewhat round. Okay? You go from one point, you start at the other point. It's not a four square shape that you will say, you know one end of the earth from the other. Alright? And the earth is made up of what? Water, and you have the land, that is. You have the hydrosphere, you have the lithosphere, then you can, the atmosphere, and so on and so forth. Alright? The lithosphere is the solid part of the earth, while the hydrosphere is the liquid part of the earth. Now, the earth, let us assume that is the shape of the earth, in the shape of the earth, right? Then you have two great lines that cuts across the earth. Alright? Now, you have one line running vertically, straight up, right? Very thick. is an imaginary line. I know you may be asking, where is the line? It's imaginary, but that's how it works. Alright? Then you have another line cutting equally into half. Alright? Now, this line that cuts vertically is called the line of longitude. It's at 0 degrees, alright? Then you have longitude. Then this line that cuts vertically is called the line of latitude. Now, this latitude is at what? Latitude is at 0 degrees. 0 degrees. Lat. Now, the scientific name for the great line of latitude, that's the horizontal line now, is called the equator or equator, as some people call it. It's actually equator, not equator. Alright? Then you have the vertical line, which is the line of longitude, known as the Great Meridian. Now, let's just use abbreviations, okay? Meridian. The Great Meridian. Now, how does it work? You see, when you want to calculate anything that has to do with latitude and longitude, you have to adhere to these two great lines. Now, if you're talking about positioning, we will still do, I will still explain the reason why you have difference in positions, why your GPS can capture a particular location. Now, before we move ahead with calculation of the difference in the lines of longitude that gives rise to difference in local time, and the lines of latitude that gives rise to the difference in locations, spatial locations, right? We'll go ahead and name these great lines. You see these great lines, they are called the cardinal points of the Earth. Now you have the northern cardinal point, you have the southern cardinal point, you have the western cardinal point, you have the eastern cardinal point. Now, when you cut the Earth horizontally, you have what we call the northern hemisphere. You know, from here up is the northern hemisphere. Then from here at the equator at 0 degrees, as it cuts down, you have the southern hemisphere. And that was why somebody like Maria Makeba was singing a song and she was talking about the northern hemisphere and the southern hemisphere. It's not it's a geographical science, guys. Right? Okay. Now, as the Earth cuts vertically, right, you have the degrees increasing from 0 at any position of the Earth, as this vertical line is, this imaginary vertical line is 0. If you are at this point, you are at 0 degrees. You are at this point, you are at 0 degrees. You are at this point, you are at 0 degrees. Now, it increases by degrees, you know, towards the west. Then you have the westings, right? So, as it is increasing, every 1 degree away from the Great Meridian, or the center of the Earth that cuts vertically, is 4 minutes. Now, every 15 degrees, every 1 degree is equal to 4 minutes. This is how bright minutes, okay? Then every 15 degrees is equal to 1 hour or 60 minutes. 1 hour, or you can call it 60 minutes. Now, if it was 60 seconds would be like this. This sounds right, geography. Alright? Now, meaning at the northern hemisphere or south, and you say longitude, maybe 45 degrees, 10 minutes, and to the west, meaning towards this side. When they say east, it therefore means towards this side. Now, we also have the coordinate system of a particular location on its own. They understand as it concerns the whole globe. Alright? Now, let us say you are at longitude 45 degrees 10 minutes west. If I am at maybe, let's say, longitude 10 degrees 3 minutes west, how I will understand the difference in time between you and I is simple. I will just do 45 degrees 10 minutes minus 10 degrees 3 minutes. What I should have to be 35 will be equal to 35 degrees 7 minutes. Right? Now, if every 15 degrees is 1 hour, then you have 2 hours. If every 15 degrees is 1 hour, then how many minutes will be 5 degrees? Every 4 degrees is what? Is 15 minutes. Right? 15 minutes. And every 1 degree is 4 minutes. So you will just do 4 plus what? 15. And you will have what? You will have 24 minutes. Then you have plus 7 minutes on 24 minutes. You have 31 minutes. Right? So the difference between you and the person will be 2 hours. What? 31 minutes. Very simple. It's just understanding that 1 degree equals to 4 minutes. 15 degrees equals to 1 hour. Right? Then you come back and say, if this person is at the west, I'm at the west, then the person is far behind me, the person will be losing time. Right? Now, by losing time, I mean that if this is 2 o'clock in my own place, then it may be what? It will not be 2 o'clock in the place of that person. Where the person is at, the person will be recording maybe 11 something o'clock or 12 o'clock. It's just simple. Alright? Now, if the person is ahead of you, maybe towards the east, where the west is, as the line cuts vertically, it gives you the west. As it cuts vertically from the Great Meridian, it will also give you the eastings. If it's areas towards the east, or an area towards the east, or all of you are in the west from the Great Meridian, but the person is towards the east, in that location. The person will be gaining time when you will be losing time. Now, this is just the reason why there is difference in local time. Now, as the lines of latitudes are, you want to know the position of a place, right? If they say the place is located at latitude 23 degrees north, maybe you count from here to here, 23 maybe here. Now, longitude, maybe 35. Alright, west or east. It will be telling you if the position of that place is at this point from the Great Meridian or from that position or at this point. Now, if it says latitude 23 degrees south, you know it's from the equator, is towards the south. Now, if it says longitude 10 degrees east, you come here. You know, you count the line of latitude, you just start counting from here, here, and say towards the east, therefore from here, count from the Great Meridian, or from that position. Alright? The same thing. If it says west, you come here. That is the reason why you have to be careful. Like when you make enemies with people that are geographically inclined, when you make enemies with technical geographers, you have to be careful. They'll be able to calculate even your location. Alright? Alright. So now they will calculate your location based on your elevation using a contour map or a contour image area. A person will be able to set something, set a missile straight up, just calculating. Like they do some computer work or they do some geography, technical geography, and just locate you, the exact position where you are, and just send the missile. And it will just get here, right? Then that's not the reason for this. What we're saying is that you have to be smart so that you don't sound like the case of paranoid schizophrenia to people. You know, like if I'm just working or sitting and I just hear somebody say, "Good afternoon, hello, good afternoon, how are you?" in the morning, and I think there's something wrong with this person. Or somebody saying, good night, sleep tight. In the morning, in their location, like what the heck? Like, you know, a couple of times, guys, I would like to feel like I've had to say good morning to some people and you say good night. Then I wish I could send some butterflies. You know, when I'm just waking up, like I want to send butterflies to my loving Chile. I want to send butterflies in the morning to my world in Santiago. Even though it's morning, I'm just waking up in my location. Yet, I want to send him sweet good night butterflies for him to sleep well. That's because of the difference in the lines of latitude, position of the earth based on latitude. So you see, it's no rocket science. Like you want me to teach you to say from here to here, maybe you have 23.5 degrees, maybe tropical Cancer, tropical Capricorn. Is that what you want to hear me say? Oh, you want us to go 66.5 degrees, and so on and so forth. I hit the North Pole and the South Pole. That's not what we're doing now. We're talking about what? Difference in local time. This is how simple to calculate the difference in local time. So now let us say this is point graphic representation of the earth. Let's say you have South America here as a continent, North America as a continent. Now this is at the longitude, women